This conference will now be recorded.
All right, this is the review for Unit 2. We're looking at some of the problems that were either requested by email or kind of we didn't get to that area during the review day. So I'm looking at 3B on the non-calculator portion, and we want to know how to simplify this following expression into a single expression, which means just a cosine, a sine, or a tangent, depending on what it is. So the problem with this one is it's kind of written funny. You kind of have to write the whole thing on one line to see what's going on. So notice the key factor here is that this is either going to be an addition or subtraction problem. And it is cosines are stuck together and sines are stuck together. So this is going to reduce down to a cosine. And remember, when the cosine formula is used for adding or subtracting, it's always the opposite sign of your original. So that means this originally was a minus. So this is 243 minus 121 inside using the two angles that were provided. So that is going to be minus 121. It's going to be 122. So this reduces down to cosine of 122 degrees. And we're not evaluating it. That's just a single expression instead of a multiple expression. So you're just using your formulas. Then on the non-calculator portion, we also did not get to much with the polar coordinates and rectangular coordinates. So this says change to the polar coordinates to rectangular coordinates, and the rules for that is that we know that x is r cosine theta and y is r sine theta. So this is -2 times cosine of, if you don't like negative 7 pi over 6, remember you can add 2 pi to it, which would be 2 pi over 1, so times that by 6 over 6. So -7 pi over 6 plus 12 pi over 6 is 5 pi over 6. That's really the angle we're working with if you wanted to convert that to its coterminal. So -2 times sine of 5 pi over 6. And remember that 5 pi over 6 is a 30-degree reference angle in quad 2. And that means that it's negative square root of 3 over 2 and positive 1/2 for its ordered pair. So this first guy is -2 times the x value, so that's negative square root of 3 over 2. The 2's are going to cancel, and the negative times negative is positive. So that's our x coordinate. The y is -2 times 1/2, which would just be -1. So this is the ordered pair for D. It's square root of 3 comma -1. Okay, and then for number 7, we're changing from the rectangular coordinates to polar. And in polar, we have to be specific. We're going to use no negative r's, and we want our theta to be, what would the angle be between 0 and 2 pi? So the first thing I like to do is draw a picture of where this is located. This is a positive x and a negative y. That means it's in quad 4, just based on how the ordered pair is. This is the length of the x-axis. This is the length of the y-axis part. And we can use Pythagorean theorem. So x squared plus y squared equals r squared to find r. That's 25 plus 25 times 3, because you have to square both parts of that. That's 25 plus 75. So that's 100 equals r squared, so r equals 10. Now, so that means that my r is 10, so this is going to transform into the point 10 comma something. Now, we already kind of know what this is just based off the picture we've drawn. If you divide everything by the hypotenuse, you'll see that this ends up being a square root of 3 over 2, and this is a 1/2, and square root of 3 over 2 is across from a 60-degree angle. So that means this is 5 pi over 3. Another way of finding that is doing tan of theta equals opposite, which would be -5 square root of 3 over 5 over adjacent. Reduce that down. That's a negative square root of 3 over a 1, which means it used to be negative square root of 3 over 2 over 1/2. And remember, a tangent's always y over x, so that's 1/2 and then negative square root of 3 over 2, because this is quad 4, so positive x, negative y. And we would notice that that was on the unit circle, that is still the 5 pi over 3. So that theta is 5 pi over 3. Okay, so that's that one. Now for the calculator portion, we're going to do a few examples from this. This first one, we need to solve this, and it says exact solution, which means this should be able to be solved using either unit circle, or we just leave things as like the arctan of a value. First thing I would do here is to subtract over the 3 tan theta, so you get all your tans on the same side, and then pull a tan theta out since they have one in common, so that then is tan squared theta minus 3. We solve each part equal to 0, so tan theta equals 0, or tan squared theta minus 3 equals 0. We need to add the 3 to the other side and then take a square root. When we take a square root, you have to remember to put plus or minus, or you're going to miss a whole possibility. So it's either positive square root of 3 or negative square root of 3. Okay, so let's talk about when cotangent of theta equals 0. That happens when the y value is 0, not the x value. So that's the points on the x-axis. So that would be 1, 0, and negative 1, 0, because that's y over x equals 0. So that would be theta is going to be true, and we're doing just 0 to 2 pi, so we don't need to add the plus 2 pi k. So this is pi and 0. So there's 2 of the answers. Tangent is square root of 3, and that would be over 1. So that would be, remember, square root of 3 over 2 over 1/2, which means our ordered pair was 1/2 square root of 3 over 2, or negative 1/2 negative square root of 3 over 2. So remember, that's in these two quadrants. And then that is an x value of 1/2, so that's short. The y value is taller. Those are the pi over 3s. So pi over 3 and 4 pi over 3 for this branch. And then for this branch right here, it's going to be the same thing, but in the other two quadrants because it's a negative tangent. So that's going to be 2 pi over 3 and 5 pi over 3. Same exact reference angle. So there are 6 solutions to that one. Okay, we're going to use the information provided here to find sine of alpha plus beta, cosine of a half angle, and tangent of a double angle. Excuse me. So first thing I'm going to do is draw a picture for each of these in their correct quadrant and then label what I know and find the missing pieces. So for alpha, we're in quad, that's 4, 270 to 360. And the sine of this alpha right here is negative 3 over 5, and that's opposite over hypotenuse. Use Pythagorean identity and find out that this side is positive 4, because in quad 4, x's are positive but y's are negative. So that means I can also write that cosine of alpha is 4 over 5 and tangent of alpha is negative 3 over 4, just in case I need those. To do beta, you probably want to subtract 360 since these are too big from both of those. That would be 0, 180 for this one, and that would be 270. So for beta, we're in the 180 to 270 range, so that means we're in quad 3. And then our cosine of beta is negative 15 over 17, and hypotenuse can be never be negative, so it has to be the 15. And then we would use Pythagorean identity, so 17 squared minus the 225, because you square 15 and get 225. That's 64, and the square root of that would be 8, but in quad 3, it's a negative 8. So that means that I already know cosine, so sine of beta is opposite over hype, and tan of beta is opposite over adjacent, so 8 over 15, because negative over negative is positive. And then the final picture is for this one. You can add 360 if you want to get those to not be negative. That would be positive 180 and 90, I believe. Yeah. So that's in quad. 90 to 180 is quad 2. So gamma is in quad 2. And we know that tangent is negative 12 over 5, so opposite over adjacent. And in this quadrant, the x's are negative and the y's are positive. So that is 144 plus 25. That's going to be 169, which is 13. So that means that I know tangent, so sine of gamma is 12 over 13. Cosine of gamma is negative 5 over 13. So you kind of need all of that information and to know your formulas to be able to solve these problems. So let's do A. So sine alpha plus beta, all in one parentheses. We use our formula for adding sines, so that's intermingling the sines and cosines. So sine of the first angle, cosine of the second angle. And remember, sine is social, that's what this means, and agreeable, so we keep our plus. And then it would be cosine of the alpha and sine of the beta. So then we just grab our important pieces. So sine of alpha was negative 3/5. Cosine of beta was negative 15 over 17. Cosine of alpha was 4/5. Sine of beta was negative 8 over 17. So 3 times 15, because they're both negative, so that's going to be positive. That's 45 plus a negative 32 over whatever 5 times 17 is, which is 85. Then we need to subtract the 45 minus the 32, which is 13. So this first one is 13 over 85. If I jump and do F next, that's tangent of a double angle formula. So the double angle formula for tangent is 2 tan of the original angle over 1 minus tan squared of the original angle. So where is gamma? So we need tangent of gamma, which was negative 12 over 5. So 2 times negative 12 over 5 over 1 minus negative 12 over 5 squared. Okay, so that would be negative 24 over 5. 1 minus 144 over 25, because that would get squared and become positive, but you still have subtraction in front of it. I would multiply everything on top and bottom by 25 to clear out those fractions. So that 5 goes into 25 and leaves me with a 5, and then I have to times that by the 24 that's negative. So that'd be negative 120 on top over 25 minus 144. So 25 minus 144 is negative 119. So that's negative over negative, so that'd be positive 120 over 119. Okay, and the last one of these, we want to do the half angle. We're going to use cosine of gamma. So for H, cosine of gamma over 2 is the formula, plus or minus the square root of 1 plus cosine theta all over 2. All that's in the radical. To know if we're choosing plus or minus, we have to look at our information about where would gamma over 2 be. So if gamma is in the 90 to 180 range, so imagine cutting those in half. That would be 45 to 90. That puts that in quad 1. And in quad 1, everything is positive. So because gamma over 2 would be in quad 1, that's why we choose the plus. So I just don't even need to write anything in front of it. And then cosine theta, excuse me, that's gamma, not theta. Cosine of gamma was negative 5 over 13 times everything on top and bottom by 13. That's going to be 13 minus 5 over 26. 13 minus 5 is square root of 8 over square root of 26. You can reduce if you would like, because they're both divisible by 2 and it's just dividing here. So that would be square root of 4 over square root of 13, which is 2 over square root of 13. And if we rationalize, we get 2 square root of 13 over 13. Okay. So that puts us into number 11. I couldn't remember which one you guys asked for, so I just picked one. It did not get copied down correctly into my notes. So 12 so if I think of like x being cosine theta for this one, then this would be 12x squared plus 11x plus 2 equals 0. So I want to try to factor this, but I don't believe it will, because 12 times 2 is 24. And factors of 24, oh, actually this one might factor. Let's see, that'd be 3 and 8. So if we factor that, pull a 3x out of the first pair, that leaves me with 4x plus 1. Pull a 2 out of the second pair, that also leaves me with 4x plus 1. This would be 4x plus 1 and 3x plus 2. So we get x equals -1/4 and x equals -2/3. But remember, x was cosine. So here's where we get the problem where we need answers that are not going to be on the unit circle, which means we're going to use decimal approximations. So there is no -1/4 or -2/3 on the unit circle for cosine. So we have to do the inverse cosine as long as this is between -1 and 1, which they both are. So cosine inverse of -1/4 and cosine inverse of -2/3. And we want our answer in degrees, I believe. Let me look at the directions. Yes, in degrees from 0 to 360. So the problem is there's always two places cosine can be negative. So even though our inverse one will give us an answer here, we're going to get another answer down here. So we have to make sure we get both. So let's do the cosine inverse, so -1/4. And then we want to take the cosine inverse of that. That is 104.5 degrees. Did it say round to 2 decimal places? Yes. Okay, so let me go back. That would be 48 degrees. Now remember, that is the measurement from 0 for that angle, so that is definitely one of our solutions. But there is another solution in this group. You can do it one of two ways. You can find this reference angle and then add that to 180 to get down here, or because this is a cosine relationship, it is the same reflection this way. So you could do 360 minus 104.98 to figure out what this is. So 360 minus 104.48 is 255.52 degrees. That's supposed to be a 4 right there. Okay, so excuse me. We're going to do the same thing for this guy. So that's 2/3, and it needs to be negative. Inverse cosine, and that gives me 131.81. Again, in quad 2. And this time I'll do this one a different way. So if I wanted to use the reference angle, I would subtract that from 180 and figure out that that's 48.19 right here. And then I know that this is an identical reference angle, so I could do 180 plus that. So just showing you two different ways to do it. So plus, actually let me just minus since I'm already negative. The 180, so I know this is giving me a negative angle, but I'm adding it. So 228.19. Okay, so my angles are also 131.81 degrees and 228.19. Okay. And then for this last guy, we've got the problem where this is the original point. 4 pi over 3 is down in quad 3, has a radius of 7, and this is the angle. Now the question becomes, out of the angles they gave me, do any of these match with the original location of this polar coordinate? The way we check this is we check the angle first, and if it ends up in quads 2 or 4, it's never going to match this, so you pretty much know it's done for. If it ends up in quad 3 and the 7 is positive, that matches. If it ends up in quad 1 and the 7 is negative, it flips it the other direction and then it will match. So the negative, so pretty much you find where your angle is and then you say, is the 7 positive or negative? And you flip if necessary. And wherever you end up, you ask, is it the original location after you've done both steps? So the first thing you want to do is you really want to figure out where these angles are. So remember, you can subtract 2 pi multiple times if you need to. And if we're using pi over 3s, that's kind of what we're counting by, then we need to know that 2 pi over 1 with a denominator just like that is 6 pi over 3. So if we subtract 6 pi over 3, that would give me 10 pi over 3. Subtract it again because that's still too big. That'd be 4 pi over 3. So that is the correct location. And the 7 is positive, so that means it doesn't flip, so that is good. Another way of doing these is to count around. Remember, pi over 3s occur at, that's 60 degrees, so it's 1, 2, 3, 4, 5, 6. There's 6 of them around. So if we're doing negative 10 pi over 3, that'd be 1, so negative 1, negative 2, because we're going this way, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. So negative 10 is in quad 2 and the 7 is positive, so that does not match the original. Okay, so this one might be a little tougher, so I'm going to add 6 pi over 3 a couple times. That'd be 12 pi over 3, so that'd be negative pi over 3 if we add it to this. And that's here, so there's where negative pi over 3 is, and then they have a negative 7, so that means we flip across the diagonal, and that still does not match the original angle and radius. 7 pi over 3 is actually right here because 6 pi over 3 is 2 pi, and then they have a negative 7, so we're going to flip it down. That matches the original location. Negative 2 pi over 3 is negative pi over 3, negative 2 pi over 3, so that's here. And they kept the 7 positive, so we stay where we're supposed to. 8 pi over 3 would be pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3. So that's not going to ever match even if it was flipped. And then negative 5 pi over 3 would be negative pi over 3, negative 2 pi over 3, negative 3 pi over 3, negative 4 pi over 3, negative 5 pi over 3 is in quad 1, and it has a negative 7, which means it flips across and matches with this one. And then 11 pi over 3, I don't know that one off the top of my head. If I subtract 6 pi over 3, which is a 2 pi, I get 5 pi over 3. So 5 pi over 3 is located in quad 4. And even with a negative 7, it'll flip to quad 2. It does not end up in quad 3. All right, so this is the video I created for you guys. Hopefully this will help with some of your questions. I'm also going to send a link to my playlist from fall, it was either fall or spring of last year, because I did a lot of the unit review there. But it is a slightly different review. The class was slightly different in spring, I think is when it was. But if you want more examples or if you want reteaching on some of the things, that might be a good place to look as well. But spend most of your time focusing obviously on the review for this current version of the test. And I will see you all Monday.